Hi, welcome to Celltomic, and today we are going to cover our last part of our mole series. In the first video, we learned how to find moles using the mass and the Avogadro's constant. In the second mole video, we learned how to find mole in solutions by using the grams per dm cube or moles per dm cube. In this video, we'll be learning how to find mole in gases. So, finding mole in gases using the volume. So, molar volume is actually the volume occupied by 1 mole of gas. So the molar volume at a fixed pressure and temperature is the same for all gases. So what does this mean? So let's say we have a CO2 gas at 1 atm. atm is the pressure, and at 25 degrees Celsius. And let's say we have a hydrogen gas at 1 atm and also at 25 degrees Celsius. From this, we can see that they have the same pressure and the same temperature. So this means that the number of moles of CO2 and H2 is actually the same. So there'll be the same amount or the same number of moles of CO2 gas and H2 gas in 1 atm and 25 degrees Celsius because the conditions are the same. So 25 degrees Celsius and 1 atm is actually the room temperature and pressure, also known as RTP. So the molar volume for RTP is actually 24 dm cube. So remember this number, 24 dm cube. Another way is standard temperature and pressure. So standard temperature and pressure has a condition of 0 degrees Celsius and 1 atm. The molar volume for standard temperature and pressure is 22.4 dm cube. So how do we find the mole using this volume? So the mole is actually the volume divided by the molar volume of the gas. So this can be in terms of RTP or STP, where RTP is 24 dm cube and STP is 22.4 dm cube. And that's how we find the mole. So now let's look at an example. So in this example, we asked to find the number of moles of CO2 particles in 500 cm cube of CO2 gas at RTP and at STP. So before we do anything, we first need to convert cm cube to dm cube because we need to remember that our molar volume of gas are all in dm cube. So if you have catch mole part 2, you will know how to convert cm cube to dm cube. So to convert cm cube to dm cube, we first take 500 divided by 1000. And this will give us 0.5 dm cube. So now we know that there's 0.5 dm cube of CO2 gas. So now we can find the number of moles in RTP and in STP. So in RTP, we know that mole is equals to volume over the molar volume. So this is equals to 0.5 over 24. Why 24? Because now we are looking at RTP, and this will give us 0.0208 mole. Okay, now we look at STP. For STP, same thing, mole equals to volume over molar volume. So STP, the molar volume is 22.4, and this will give us a value of 0.0223 mole. And that's how we find the number of moles in gas. And that's the end to our video. I hope that through this mole series, you have learned how to find mole using the mass, using the Avogadro's constant. You have learned how to find it in solutions in mole per dm cube and grams per dm cube. And through this last part, you have finally learned how to find mole in gases. So continue to support us and continue to watch our videos. And remember to always stay curious.